In this video, we will learn to identify different types of numbers. And so in this lesson, we are dealing with what we call the real number system. And believe it or not, there's an actual thing called an imaginary number system. So here, the real number system is basically anything you see on a day-to-day basis. So real numbers could include fractions, decimals, could include negative, positive numbers, it could include square roots, could include the number 0. All of that would fall under the real number system. Now, under the real number system, we have different types of numbers. So here, we see all the different types. So we have two main categories under the real number system. We have rational numbers and irrational numbers. So rational numbers would be anything you could write as a ratio, or in other words, a fraction. So notice it could include negative numbers, like -2, could include the number 0, could include positive numbers like 4, could include decimals like 4.5, could include fractions like 1/2, and it could even include repeating decimals, because repeating decimals you can actually write as a fraction. For example, 0.3 repeating we can write as 1/3, which is a fraction. Now that is as opposed to irrational numbers, which would include any decimals that keep going on forever and ever and ever. That is not repeat. So for example, pi, which is used in geometry, it's irrational because it's a decimal that keeps going forever. It is 3.14159265535, etc. So pi is irrational because it keeps going on forever. And any square root that is not a perfect square, like the square root of 3, the square root of 10, etc., those would all be irrational. And then here we see 0.6843, etc. So it's not repeating. So this would also be irrational because it keeps going on forever without repeating. Now under rational numbers, we have more specific categories. So integers is the next category. And this would include any negative number or 0 or positive number that is not a fraction. So this would not include things like 1/4 or -2/3 or 3.7. Okay, none of those would be integers. It's just going to be numbers without fractions. Could be negative, could be 0, and it could be positive. Now more specifically, we have what are called whole numbers, which is a subset of integers. So whole numbers are also integers, but more specifically, whole numbers start at the number 0 and count up from there. So like 1, 2, 3, 4, etc. would all be whole numbers. And then under whole numbers, we have even a more specific category, which would be called natural numbers. And natural numbers start at the number 1 and count on from there. All right, and a quick way to remember whole numbers is whole number has a 0. It starts at 0. And so the number 0 literally looks like a hole if you draw it. So the 0 is a whole, and that would be also a whole number. All right, so that is maybe an easy way to remember whole numbers. Now we mentioned kind of at the beginning that we have such a thing called an imaginary number system. We're not going to talk in detail at all about that, but in case you're interested, I do want to point out that imaginary numbers would be any square root of a negative number. So for example, square root of -16, that would be imaginary. And that is totally separate from what you see on this slide. Imaginary numbers are a totally different thing. So any square root of a negative number would be considered imaginary. So now we're going to deal with some examples. So that is the content of the lesson. Now we're going to deal with specific examples, and you can use this to quiz yourself to see if you understand the concepts. So I have a few different numbers we're going to go through. And the first number is the number 8. So yes or no, is the number 8 a real number? So yes, it would be real because the only things that are not real is square roots of negative numbers. So next question is, would it also be rational? Well, yes, it is rational because the only thing that is not rational would be decimals that keep going on forever without repeating. So yes, it would be rational. Now, would it be an integer? Well, yes, integers need to not have any fractions in them. 8 does not have a fraction, so therefore, yes, this would be an integer. Now, would it be a whole number? Whole number, yes, it would, because whole numbers start at 0, go on from there, so like 0, 1, 2, 3, etc. And 8 would be in that category. Now, is it a natural number? Again, this would be yes, because natural numbers start at 1 and go on from there. So 1, 2, 3, 4, etc. So 8 would be all of these. Now, what about the number -8? Is this real? Well, yes, it is real, because the only thing that is not real would be square roots of negative numbers. So yes, this is real. And would it be rational? Well, yes, it would be rational as well, because the only things that are not rational would be decimals that keep going on forever and ever. So it does not do that, so this would be rational. Now, what about an integer? Yes, this would be an integer, because integers include negative numbers, 0, and positive numbers, as long as there's no fraction within the number. So there's no fraction, so yes, it would be an integer. Now, would it be a whole number? It would not be a whole number, because whole numbers start at 0 and go up from there. So this is below 0, so this would not be whole. Now, lastly, would it be natural? The answer is no, it would not be natural, because natural numbers start at 1 and go up from the number 1. So 1, 2, 3, 4, etc. So no, it would not be natural. The next number is number 3/4. Is it real? Well, yes, it is real, because the only thing that is not real would be square roots of negative numbers. Next question is it rational? Yes, again, this would be rational, because rational numbers need to be can be written as fractions. The only thing that's not rational would be our decimals that keep going on forever without repeating. Next question is it an integer? Well, no, it is not an integer, because integers cannot be written as a fraction. So this would be no, which means it's going to be no to all the other ones. It's not whole or natural, because whole or natural numbers cannot have fractions either. So it's no for integer, whole, and natural. The next number is 0.4 repeating. Is this real? Yes, this would be real, because the only thing that's not real would be the square roots of negative numbers. What about rational? Well, yes, this would be rational, because the only thing that is not rational would be our decimals that keep going on forever without repeating. This does repeat, even though it goes on forever, it does repeat, which makes it rational. Next, would this be an integer? Well, no, this is not an integer, because integers, by definition, will not be allowed to have decimals or fractions in them, so this would be no, which means that it would not be whole or natural either, because whole numbers cannot have fractions, neither can natural numbers. Next number is the number 0. Is 0 real? Yes, it is real. The only thing that's not real is the square roots of negative numbers. Is it rational? Yes, it would be rational, because the only thing that is not rational would be our decimals that keep going on forever without repeating. Would it be an integer? Yes, it would be an integer, because integers By definition, are numbers that would not have a fraction in them when you write it, and this does not have a fraction in it, so yes, it would be an integer. Next, would it be whole? It is a whole number because whole numbers start at the number 0 and go on from there. So 0 is where the whole numbers start. So yes, it would be a whole number. And then lastly, would it be a natural number? This would not be natural because natural numbers start at 1 and go up from there. So this would not be natural. Let's take a look at one more number. And that number is the square root of 18. So first, would this be real? Yes, it would be real because the only numbers that are not real are the square roots of negative numbers. Would it be rational? Well, rational numbers would include everything except for decimals that keep going on forever without repeating. And this, when you take the square root of something that's not a perfect square, you get that. You're going to get a decimal that keeps going on forever without repeating, which makes it not rational. And because it's not rational, it can also not be an integer or a whole number or a natural number. Because an integer, by definition, cannot, it needs to be rational. Integer cannot have decimals or fractions, and this will have a decimal going on forever, which makes it not qualify as an integer, which would in turn make it not whole and not natural. So that concludes our lesson for today, and we will see you next time.